I've got to revise chemistry. Let's get on to it. Details filled out. Candidate number. Well, if you must know, it's 07442. Question 1. The neutral lambda particle AO is a baryon with a strangeness of -1. Crazy. One possible decay for AO is that. Deduce the quark structure of AO. Quark. What the hell does quark mean? Oh my god, wait. It just hit me. It just hit me. Baby, hit me one more time. Quark means 4. Because anything with quart in it means 4. Like quarter, quaternary. You got the threesomes and you got the quarsums. You know what I'm saying? They call me the master of quarsums. To deduce the quark structure, draw a 4-sided shape. So the hardest A level is telling me for question 1, draw a square. Draw a square. Alright then, let's go. 1.2. State and explain which interaction is involved in this decay. Interaction. Which interaction? Interaction. Interaction. I need some action in my life. I need a wife who is my type. We'll never fight. 5'4" in height. But I could go shorter. I want 5 daughters. Okay. Let's move on. I don't get this question. Let's move on. An antiparticle. I wonder why I don't get this question. An antiparticle of the neutral lambda particle decays into a neutral pion and particle X. Identify X. Well, there's no X in the equation. There's only A, pi, and N. So this is a this is a trick question. Of course, AQA. Of course, they're giving me bloody trick questions. 1.4. The rest energy of AO is equal to the energy of a photon with a frequency of 2.69 times 10 to the 23 Hertz. Determine in MeV the rest energy of AO. What? Determine the rest energy. I got 99 marks out of 100 in class in my English questions. I get the same if I did it again because I still don't know the definition of rest. There you go. Shout out Dave. Shout out Dave. Hopefully me and him collab one day. Because I got the bars, as you saw earlier, across the page. Oh, genuinely, I'm on fire. I'm on fire. I'm on fire. Put me out. Put me out. Put me out. Put me out. 1.5. The discovery of particles such as the AO is made by large international research teams. Suggest one reason for this. Right, the word that jumps out at me here, international. And when they're talking about international, you know what they mean? The first answer that came to my head was cheap labor. I'm quite confident with that because they work for nothing. They work for peanuts in third world countries. So cheap labor, let's go. And that's it. Question 1 done. And I think we might have got pretty much full marks. Let's go. Question 2. Question 2. It's looking good. It's looking good. I don't want to read all that. Calculate and S the time taken for the car to complete the other run. Okay, maybe we do need to read a bit of it. Wait, the time taken? Surely? No way, no way, there's no way A-level physics is asking me a simple speed, distance, time calculation. What is going on right now? Time is distance over speed, isn't it? So it's just 1.61 over 343. Surely. Wait, why is there 1,1230 right there? Nah, that's just to throw me off. They play mind games on the previous question with identify X. I'm trying to throw me off again. I don't believe it. 2.2, let's go. It's a graph question. It's a graph question. It's okay. We don't need to read any of that anyway. Determine the kinetic energy of the car at its maximum acceleration. Kinetic energy? That's chemistry. That's half mv squared. So half of the mass times by, where's v? Oh, we probably read it from the graph, don't we? 470. Half 6.5 times 10 to the 3 times by 470 squared. You know what? 717 million? That looks right to me. That God, for the wrongest answer I've ever put in my life. Question 2.3. Calculate percentage of the input power used to accelerate the car as maximum acceleration, 4 marks. You're asking the wrong guy, buddy. That's not for me. Alright, question 2.4. Scientists recommend the average driver of the car should be less than 3 grams. The average... Oh, the average deceleration of the driver of the car should be less... I was going to say, should be less than... What kind of driver are they getting that's less than 3 grams? They're getting air to drive a car. So deduce whether the average deceleration is less than 3 grams. How about no? How about I just didn't deduce it? You ever thought about that, AQA? Food for thought, yeah? Food for thought. Question 3. I can't lie, the first 2 questions were so free. Easy full marks, even though somehow full marks, even though I missed a few questions out. Question 3. In figure 2, the cell has EMF and internal resistance R. The current in the circuit is I. The potential difference across R1, V1. Explain how the law of conservation of energy applies in this circuit. Wait. I know this law. Energy cannot be created or destroyed. Surely that's my answer. You should consider the movement of one... No, I'm not going to consider anything. That's my answer. Energy can't be created and destroyed. There we go. I also put 1 coulomb of charge goes around the circuit because it said told me to consider it. 3.2. The sliding contact C is moved to end B of the variable resistor. The switch is closed. Digital voltmeter reads 2.89. Show that R is... You know what? I'm not going to show it because... What have I got to prove to them? But what's more important is what I can prove to myself, and I know that I can do that question. So 3.3, let's go. C is at 1/5 of the distance between A and B. The thickness of the conducting layer is uniform, so the resistance between A and C is 25 ohms. Determine the voltmeter reading at this setting. I just sort of did a little diagram, 25 ohms, right? And I can't lie, the thickness of that conducting layer, wow, that makes me weak. That was the wife I was talking about in my freestyle earlier. I don't have an answer to the question, but 3.4, let's continue. Ooh, 3.4, 4 marks. 3.5, let's go. I can't lie, I'm sort of skipping through the paper because I only need to get 18 marks to pass. Alright, question 5. You've got a graph here, cheeky graph. Determine using figure 11 the young modulus of the... Young modulus? Ooh, this is like a rapper or something. How many monthly listeners does Young Modulus have on Spotify? Determine using figure 11 the young modulus of the metal. I reckon it'll be something like whatever's in the middle. So it'll be like 100-ish. Explain how the graph shows that this metal is brittle. Well, you can see that the graph is pretty much a straight line, it's linear, goes through the origin. So that's what I'm going to put. We've made it onto the multiple choice, my saving grace. Thank God. Question 7. Which combination of an object's speed and journey time gives a distance travelled of 1 millimeter? Right, well, distance travelled, distance equals speed times time, so just times them together. That's option A. Because 10 times by 100 is 1,000 micrometers, which is 1 millimeter. There we go, A. Question 8. A person jumps as high as she can from a standing position. What is a reasonable estimate of her speed just after she leaves the ground? Well, if you're jumping from a standing position, it can't be that high. But I can't say 2, because the thing is with these ones, you never want to say the lowest option, and you never want to say the highest option. You always want to go with somewhere in the middle. Hold on, let's give it a little try. Okay, that was 4. I was still in my head. That was 4. Which combination of N and Z gives a nucleus with the greatest specific charge? Well, the greatest charge is always going to be the one with the most protons. The D. I feel like I've actually got 3 marks. I think I've actually 100% so far. Right, 10. Which statement about muons is correct? They include pions and kaons. Now, those are made up words, so it's definitely not B. I don't think it's A. They are subject to the strong interaction. Could be that one. They decay into electrons. Actually, no, it's D. They decay into electrons because muons electrons. So it's in the name as well as on the tin, really. So D. Question 11. Oh God. What are E, F, and G? Alright, so E, it could be an up or down. Definitely a down quark. I mean, it's all the way down there. Depends on G. Well, G's going in the same direction as F. So they got to like match each other's energy, match each other's vibe, match each other's freak, you know? So whatever F does, G's doing the same thing. So if F is going up, G must be the B plus because it's also going up. So I'm going to go D. Question 12. That's a maths one. That's a maths one. I'm not doing that. C. C. C's always right. If you're not sure, just pick C, trust me. Oh my God, 13. What the hell is all that? What change could produce a second pattern? Decrease in the kinetic energy of the electron? Yeah, sure. Let's just go for A. I don't know. That one calls out to me without even reading the other options. A. Question 14. Looks like a maths one. Maths one, we're just going to go C. A standing wave is created on a string. Which statement about the two waves that create the standing wave is not correct? A is definitely correct. C is definitely correct. B, constant phase relationship. Now, I reckon their relationship's quite healthy. I don't think they're in any situationships, any friends with benefit, that sort of thing. I don't think they're in a phase relationship either. I think they're just in a constant state of happiness. So I'm going to go B. 16. That's a maths one. We're going C. We're going C. 17. We don't read the top. What happens to the width and brightness of the central maximum of okay, we need to read the top. Okay, so slit width is increased, but that doesn't mean the width increases. So it width could decrease, so C or D. The brightness is illuminated. We're going to go C. Decreases increase. Question 18. It looks like a maths one. C. Question 19. What quantities can be calculated from the gradient of the graph and the area under the graph? So from the gradient of the graph, it's not power. Nah, it's force. It's definitely force. And area under the graph, well, I recognise work done in times by time. I think that was GCSE, so I'm going to go B. Question 20. Which is a pair of vectors? Vectors are size and direction, I think. Weight and work, no. Force and energy, that doesn't have direction. Displacement and momentum, I think that could be it. Acceleration and power, I don't think power is on a direction. I'm going to go C. 21. Which statement about a superconducting metal is correct? So I reckon it's either B or C. B, sure. 22. A heavy uniform trapdoor is hinged to the floor. It is held open by a rope as shown. Why is it getting kinky now? What the hell? Which arrow shows the direction of the reaction force of the hinge of the trapdoor? The trapdoor is getting pulled, so surely it's B, isn't it? 23. A sphere of mass m falls with speed v. The resistive force of the sphere is kv, where k is constant. What is the terminal speed? A is mgk. We go mgk. Yeah, that sounds familiar. Megan Fox, break up with him. You're missing out on. Well, if you could ever go for an Indian, I'm right here. 24. A trolley moves down the slope with constant acceleration. The mass of the trolley is doubled and the trolley moves down the same slope again. Air resistance, friction, and neutral. Which is correct? Ooh, it will be unchanged. Yeah, with these questions, you always want to say unchanged. It's always unchanged. So it's either A or C. We haven't had A in a while, I feel like. Have we? Oh, well, I'm going to choose A anyway. 25. Looks like a maths one. We're going C. 26. Oh my god, what the hell is that? Which graph shows a variation of tensile strengths? A. Nah, that looks too basic. C. Definitely not. What the hell's that? B. B or D? B for some reason looks like, I don't know why, but it looks like it's losing chromosomes. It looks like there's one short of a chromosome. So I'm going to go with D. 27. Oh my god. We're going to go D. Yeah, the rest look a bit off. No, D looks really off. We're going to go C. 28. 28. Oh, looks like a math. How many revolutions does each disc complete in 1 second? We want to go with the second highest. Second highest. We're going to go B. 29. We're going to go second highest. Like, we're going to do our rule second highest. Go B. 30. What is tan O? What is this aeroplane, man? Okay, tan O, D, because it's the only one that has V by itself. 31. Oh my god, end of questions. Oh my god, that must be the best feeling for you guys who do physics. Wow. 31. Which quantity has its magnitude at a minimum value when the mass is at Q? The acceleration of the mass, that does not make any sense. The kinetic energy of the mass doesn't make any sense. Potential energy of the mass spring system, the resultant force of the spring. Yeah, D. That sounds right. And we're done. Wow. All that's left to do now is mark this bad boy. So I've marked it. And did I or did I not pass? I needed 18 marks to pass. And I got 17. I was a 1 mark off. I was a 1 mark off passing physics. All my marks came from the multiple choice. I did weirdly well on the multiple choice. I don't know how I finessed my way through that. But yeah, man, so close, so close. I could taste the victory. But yeah, I guess physics really is the hardest A level. I do still think my cheap labour answer could have been right, because it did mention about the cost, but I decided to be a harsh marker. But yeah, good luck for physics, those of you doing it, and see you later.